A quadratic equation is any equation which has an x squared term as the highest degree term. So for example, x squared plus 5x minus 10 is a quadratic equation. X minus 1 is not a quadratic equation because it doesn't have an x squared term. And x cubed minus 2x squared plus 2x is not a quadratic equation because it has an x cubed term, so it's a cubic. Quadratic equations can be harder to identify if they're factorized. For example, you might get something like x outside of x plus 1, and that's actually a quadratic because if you expand it out, you get x squared plus x. With quadratic equations, we have this thing called standard form, which is a sort of form that you can put any quadratic equation into. The standard form is ax squared plus bx plus c. So a represents the first coefficient, b representing the second coefficient, and c representing the constant term. This form must be equal to 0. This means we can define a, b, and c for various quadratic equations. For example, 4x squared minus x plus 4. The a is equal to 4. The b is equal to negative 1 because there's a 1 hidden there with algebra. And c is equal to 4. So now we get into solving quadratics, and solving quadratics is simply finding the value of x, which will result in the equation being true. So usually there's either 1, 2, or 0 solutions. The first method of solving quadratics is factorizing. So in order to solve a quadratic equation by factorizing, we make sure that one side is equal to 0, then we factorize the other side and realize that in the factorized version there's two things being times together, and one of those things must be equal to 0 if the other side is equal to 0. So if you have two numbers multiplied together, one of them must be 0. This is also called the zero factor property. So for example, we might have x squared plus 6x plus 8 equals 0, and this can be factorized down into x plus 4 outside of x plus 2 is equal to 0. And so either x plus 4 must be equal to 0 or x plus 2 must be equal to 0. And in the case of x plus 4 being equal to 0, then the solution for x is negative 4. And in the case of x plus 2 equaling 0, the solution for x is negative 2. So in that example, that quadratic equation has two solutions. To check any solution, you can just substitute the values back into the equation to see if they really make the equation true. So negative 4 squared plus 6 times negative 4 plus 8 is definitely equal to 0, and therefore negative 4 is a solution. And also negative 2 squared plus 6 times negative 2 plus 8 is equal to 0, so therefore negative 2 is also a solution. So that's just a way of confirming things. You can also solve quadratics by completing the square, and this method is a little bit more of an advanced method. It can solve any quadratic equation, while factorizing can only solve some equations. In order to complete the square, we need to make the equation a perfect square. And a perfect square is a quadratic equation that can be factorized to make x plus a squared. So just x plus something squared. It usually comes in the form of x squared plus 2ax plus a squared, which means that if the constant term is equal to the square of half of the coefficient of x, it is a perfect square. So in the example of x squared plus 6x plus 9, the coefficient of x is 6, half of that is 3, and then the square of 3 is 9. And so that means that it is definitely a perfect square. And in x squared plus 14x plus 49, the coefficient of x is 14, and half of that is 7, and the square of that is 49. So that means it's also a perfect square. So if we're given the quadratic equation of x squared plus 8x plus 10 is equal to 0, then we can make this into a perfect square. And the first step of it is just to get rid of the 10 on the left hand side. So we're going to subtract 10 from both sides, and that leaves us with x squared plus 8x is equal to minus 10. And then we need to work out what number we need to add to this in order to make this a perfect square. We take the coefficient, in this case 8, halve it, which gives us 4, and then square it, which gives us 16. So we need to add 16 to both sides to get our perfect square on the left hand side. So we have x squared plus 8x plus 16 is equal to 6. Then we can factor out the left hand side into a perfect square. So x plus 4 squared, all of that squared, is equal to 6. Then we can simply take the square root of both sides which is x plus 4 is equal to the plus or minus root of 6. Now we should note here that the square root of 6 can be positive or negative, just like the square root of 9 can be plus 3 or minus 3. If you times negative 3 by itself, you'll still get to 9, so it's the square root of 9. In this case, we're looking at the positive or negative square root of 6. And then to solve for x, we simply minus 4 from both sides. So the solutions for this quadratic equation is 4 minus the root of 6 or 4 plus the root of 6. There's also a formula you can use for solving quadratic equations called the quadratic formula, and it's a general formula for finding the solutions. All we need to do is plug in the values of a, b, and c that we saw before, and we can get the solutions. The formula is actually based off completing the square. You can think of it as like a little piece of machinery that will actually complete the square for you instead of having to do it normally. So the formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so for the quadratic equation of 4x squared plus 3x minus 1 equals 0, a is equal to 4, b is equal to 3, and c equals negative 1. So we just substitute these values into the quadratic equation, and we'll get the answer, which is 1/4 or negative 1.